In this video, we're going to go over the properties of square roots, and I'm going to go over quite a few examples, all right? This is probably going to be one of the longer videos that you have during the school year, just because of the number of different examples that we need to go through, okay? So first off, in number one, we've got the square root of a product here, a times b. Okay, you can break that down as the product of two separate radicals, so you can break this down as the square root of a times the square root of b, okay? That's going to allow us to simplify radical expressions. All right, so if we've got, for example, the square root of 27, we can break 27 down to 9 times 3. Okay, we're going to talk about perfect squares in just a second, but anytime you've got a number underneath a radical, you want to look and see, does it have a perfect square factor? Okay, and 27 is divisible by 9. All right, so using this property, I can break this down as the square root of 9 times the square root of 3. Okay. Well, the square root of 9 can be simplified. The square root of 9 is 3, so I simplify that, and the radical 3 can't be simplified, so it stays the same. So 3 radical 3 would be the simplified answer for radical 27, okay? And we use that property to help us do that, okay? Similarly, if you've got the quotient, if you've got the square root of a quotient here, you can break that into the quotient of the two square roots, okay? So you can have the square root of a divided by the square root of b. And that's going to help us simplify. If we've got fractions or if we've got rational expressions, we might be able to simplify. We need to use this property, okay? So in this case, I've got a being 16 and b being 25, all right? So maybe you don't recognize that that's something that can be simplified right away, so maybe we want to break that into two different radicals, okay? Square root of 16 over the square root of 25. Both those are perfect squares, so square root of 16 equals 4. Square root of 25 equals 5. Okay, so we can use this property to help us simplify. We can use it for other reasons too. This is just one example. Okay, the square root of a variable to the second power is going to be the absolute value of a. Okay, the reason it has to be the absolute value of a is that you cannot take the square root of a negative value. Okay, so I can't have a negative value here. So this absolute value makes it always positive, okay? So same rule applies with x or y or z or whatever the case may be. If you have an even root here, okay, there's an understood 2 there, it's a square root. So if you've got an even root, when it comes out, you're going to need the absolute value symbol to ensure that that variable has a positive value. If there's an odd root here, cube root, okay, or the 5th root or the 7th root or so on, this is not necessary. You can have negative values underneath cube roots, 5th roots, 7th roots, and so on. Okay, in this video, we're not going to use this property, but I will go ahead and talk to you about this. Remember, there's an understood root that's 2. There's an understood exponent here with this x that is 1. Okay, so the root becomes the denominator of the rational exponent, and this power here, this exponent with the x1, becomes the numerator. Okay, as an example, and we'll go over this fully in a subsequent video. Notice the root 3 becomes the denominator, and the exponent for this power, y squared, is the numerator. So cube root of y squared is the same as y to the 2/3 power. Okay? All right, simplifying square roots. One of the things we're going to need to do is we're going to need to know what perfect squares are. And I'm going to give you the first 15. Okay? They keep going, of course. That list goes on infinitely. The first 5 are 1, 4, 9, 16, and 25. Okay, remember perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on, okay? So the next 5 are going to be 36, 49, 64, 81, and 100. That's 6 squared, 7 squared, all the way up to 10 squared. And then the final 5 for our first 15, 11 squared, 12 squared, 13 squared, 14 squared, and 15 squared. Okay, I suggest memorizing these first 15, at least the first 12 you should know, and then you can use other, things to get to the other ones if you need to. All right, so simplifying square roots. Square root of 8, we're going to do this just like we did property 1 up here. Basically on all these, we're going to do what we did with property 1, okay? So square root of 8. Perfect square factor of 8 is 4, okay? So 8 kind of falls between 4 and 9, so you want to go to that number and then move to the left, okay? And the largest perfect square factor of 8 is 4. You're never going to use 1 because it doesn't change anything. 8 times 1 is still the same as 8, so you'll never use 1 when you're simplifying these, okay? So 4 times 2, So remember this, the square root of 4 becomes 2, using this property up here, just like square root of 27 here. So the simplified answer for square root of 8 is 2 radical 2, okay? 50. 50 would fall right here in the list, so we want to move to the left and look for the largest perfect square factor. Well, 25 is going to be it. So 25 times 2, square root of 25 we know is 5, so the answer there is going to be 5 radical 2, okay? The 25 comes out as a 5 because it can be simplified. The 2 has to stay in because it can't. All right, 72. The largest perfect square factor is 36. Okay, I'm going to go over what happens if you don't recognize 36 as the largest perfect square factor in just a second, okay? It's easier to choose the largest one in the first step. So 36 times 2 is 72, so that's going to give us an answer of 6 radical 2, okay? Well, what if you didn't recognize 36 was a factor? Can you still get to the right answer? And of course you can, okay? So what if you recognize, well, 72, I know that's 9 times 8. Okay, maybe that's what you recognize. Well, 9 times 8 would be 3 radical 8. But then you should realize that 8 can be simplified like we did over here, okay? So if that's the case, you need to break 8 down again, okay, as 4 times 2, and then the 4 is going to come out as a 2. So that 3 stays there, this 4 comes out as a 2, and then this other 2 stays inside. So that gets me to 6 radical 2 also, okay? So as you can tell, it's easier to choose the largest perfect square factor first. It's going to save you time, but if you don't, you can still get the same answer. It's just going to take longer, okay? So moral of the story, try to find the largest perfect square, okay? Number 4, 27x to the 4th, okay? Well, we've already simplified square root of 27 up here, so we should be able to duplicate that again. Okay, the difference here is we've got an x to the 4th, okay? The even root of any variable expression, you can just divide that value, that exponent there, by 2, and you're going to get x squared, okay? But remember, when that comes out, x squared has to be positive. X squared is going to be positive, so we don't need the absolute value symbol there. But 3x squared radical 3, okay? Again, remember, x squared times x squared is x to the 4th, okay? So that's why it comes out when we simplify as x squared. Okay, let's try to do 5, 6, 7, and 8 on your own, and then come back and check your work. All right, let's take a quick look at number 5. 54, so the largest perfect square factor of 54 is going to be 9. 9 times 6, okay? X cubed I need to break down as x squared times x, and y to the 6 I need to break down, I don't need to break down because it's already going to be a perfect square, okay? Y cubed times y cubed is y to the 6th, okay? So this 9 is going to come out front as a 3. This x squared is going to come out as an absolute value of x, and this y to the 6th is going to come out as a absolute value of y cubed, all right? The 6 and the x have to stay inside because they're not perfect squares, okay? So my answer should be, again, 9 comes out as 3, x squared comes out as x, y to the 6 comes out as y cubed. Because these both have odd exponents, if they were negative, you know, I need to account for that. So that's why the absolute value is here and not here in number 4. Notice we didn't put the absolute value there because x squared is always going to be positive, okay? Absolute value has to be there if you've got an odd exponent. And then the 6x stayed inside, okay? So this is the simplified answer for problem number 5, okay? So 1 through 5 are all using that first property. All right, 6 and 7 are going to use a combination of those first 2 properties. Okay, so number 6, we break this down as the square root of 36 over the square root of 121. Those are both perfect squares. So that's going to be 6 over 11, and that's the answer. All right, number 7, we're going to break this down first as the square root of 98x squared over the square root of 81. Okay, I've already broken down 98 as 49 times 2 to save us a little time here. All right, so when I simplify my numerator, the 49 is going to come out as a 7. The 2 stays under, and then the x squared comes out as an absolute value of x. The square root of 81 is going to simplify to 9. Okay, so we should have 7 times the absolute value of x times radical 2 over 9. Okay, number 8, let's scroll back up. Understand the following, okay? If we've got square root of a plus b is not equal to the square root of a plus the square root of b, okay? So in number 8, I can't add these two together and say, oh, that's the square root of 232. That doesn't work that way, okay? With radical expressions, you treat those just the same as you do variable expressions. You can add 2x and 3x, okay? You can add 2 radical 2 and 3 radical 2, but you can't add like 2x and 3y. Those aren't like terms, so you can't combine them. So with adding radical expressions, you have to make sure they're like terms, just like you would if they were variable expressions, okay? So what we're going to do here is we're going to simplify each of these individually, okay? So square root of 32, I'm going to break down as 16 times 2. Largest perfect square factor of 32 is 16. If you use 4, you would have had to do something like this, and we want to stay away from that, okay? 200, largest perfect square factor is 100, so 100 times 2. Now, hopefully you can already tell this radical 2 that's going to stay here and this radical 2 that's going to stay here mean that we're going to have like terms in just a second, okay? But let's simplify each of these first. So we get 4 radical 2 plus 10 radical 2. These are like terms now. Imagine this being 4x and this being 10x. I could combine those. Same with radicals. So I'm going to add these coefficients. I'm going to add this 4 and this 10. My radical expression stays the same. So the answer here is 14 radical 2, okay? All right, let's try 9, 10, 11, and 12, and then check your work. All right, taking a look at number 9, we're going to use the same concept that we did with number 8, okay? This is subtraction, okay? So I can't subtract these unless they're like terms. All right, so let's simplify these and see if that's going to happen. Okay, first one, square root of 25 times b simplifies to 5 radical b, okay? b cubed I can break down as b squared times b. And I can simplify the square root of b squared, okay? So now let's simplify that part. Okay, so 5 radical b, that doesn't change, minus, remember, square root of b squared has to be the absolute value of b, okay? And then times radical b. Well, notice these both have radical b. There's a radical b there, there's a radical b there. That means these are like terms. So I've got to subtract these coefficients. 5 minus the absolute value of b. Well, I don't know what b is, so I just have to leave it like that. And I'm going to put that in parentheses times radical b, okay? So you can see if I were to distribute this, I would go back to here, all right? But the simplified answer is going to look like this. So 5 minus the absolute value of b, that quantity, times the square root of b, all right? Number 10, this is the first time we've had a little coefficient out here. It doesn't mean anything. This means 2 times this, okay? So as I simplify the square root of 40x cubed, I'm just going to have to multiply whatever comes out times this 2, okay? So 40, largest perfect square factor is going to be 4, okay? So 4 times 10. And then x cubed I can break down as x squared times x, okay? So this 4 is going to come out as a 2. This x squared is going to come out as an absolute value of x. And this 10 and this x have to stay inside, okay? So what I'm going to get is 2 times this 2, which is 4. Again, x squared comes out as absolute value of x. And then the radical 10x stays like that. The 10 stays inside, and so does this x. So that's the answer for number 10, okay? 11, again, treat these just like you would variable expressions. We're going to multiply the coefficients. 7 times 3 is 21. Square root of 5 times square root of 10 is square root of 50, okay? I want to go ahead and multiply these two together because neither of these is a perfect square. But maybe once I get this product here, 50, I can simplify it using perfect squares, okay? So 50 I can break down as 25 times 2, okay? Square root of 25 is going to come out as a 5. I'm going to multiply that 5 times 21, and that's going to give me 105. The 2 stays in, so 105 radical 2, okay? 12, we're going to use the same concept here. 30 divided by 6 is 5. Square root of 18 divided by square root of 2 is square root of 9. So that's 5 times radical 9, okay? Well, radical 9, that's a perfect square, so that's going to be 3. So I get 5 times 3, which is 15, okay? So I tried to cover as much there as I could. Again, I hate to make these longer videos, but in this case, I felt like I needed to, all right? So as you have questions, bring those to me, but the ability to simplify radicals is huge once you get into pre-calc and move on into calculus.